They don't make it nice. They don't make it nice. They just make it anyhow. Those employees that are there, they don't make nice food. And that guy doesn't care, he just put his price.
But do you know that those people who are at the service station, they enjoy when they are better than us?
They do.
You're correct. There's nothing to do. The person is waiting to be. Yes. You know, you don't want to be troubled by this place. It does not even take you 2 days to be free. You just don't come.
Which one?
I'm saying, if you want to be free from all you just do is don't come.
Yeah, no one will know that. And your Zoom classes, you just conduct. You just do your Zoom classes at home.
Hello? Where are you? Room 4. So it means today I'm not cooking.
Why?
I'm already eating.
Like that? Admit. It's a Zoom lesson. Participant, where's the waiting room?
Morning, sir.
Yes, morning. How are you? Afternoon.
Afternoon, sir.
No, it's no longer morning. It's
I was sleeping. I thought it's morning.
You were sleeping.
Yes.
You just woke up now.
Yes.
You're enjoying your life to the fullest.
No.
May I know who is this person, please?
Christine.
Christine? Oh, okay, I can see now. Right. No, I can. Christine. Okay, where are your what? Please don't cover yourself.
My colleagues.
Where are they?
They are coming now.
So they will join you on your screen. They will come with their own screen, or they will join you on your laptop.
They are coming. They are here now.
Oh, okay. So
she's here.
Okay. Yes, how are you, sister?
I'm fine now, I say.
I'm good. How are you doing?
Eh?
How are you doing?
I'm doing fine, say. What about you?
I'm fine.
Okay, how was the
Oh,
corona?
no, we don't have corona here.
Hey, okay, that's fine.
We don't want it even.
Even as we don't want it.
We don't want corona from you, so that's why we don't want you guys to come here.
Okay.
But we miss you at the school, one face to face. Ochipara
But
na
I'm
chipara.
seeing you now. I'm seeing you.
Okay.
Yes, how are you? All right, for today's lesson, we just a continuation of where we ended last week? If you were here, you can recall that I was doing it. Sorry for the noise on the background, it will disappear very soon. If you were here last week, you can recall that we were doing lessons on graphical representations of data, where we learn different types of data, the histogram, the bar graph, the line graphs, and the pie charts. Can you hear me clearly? Hello. Sorry, guys.
Yes, we can hear you, sir.
All right. Okay. For today we are continuing where we left off last week. Again, we are looking at graphical representation of data. And by the end of this lesson, you should be able to use various data representations to present your data. Remember, this topic is about statistics, and in statistics, there is a part where you have to do graph or to present your data that you have collected into various forms, like line graph, pie chart, and box plot, and stem and leaf. Okay, the line graph and the histogram, those one we did it in the previous lesson. For this week or for this lesson, we will look at the pie charts, the box plot, and the stem and leaf, and also another graph, we call it a line graphs, to present various data. So to start with, we can start with a line plot. It's also called a dot or a dot plot. Line plots are a diagram that shows the frequency of a data on a number line. And you can use any symbol, like in this case, we're going to use X, or in some cases, we can use a dot, or a dot is placed above a number. It's placed above a number on a number line each time that data is observed. So we will have, if you collected a lot of data, maybe it can be marks of students for 50 students. That mark, in some cases, you want to summarize it. And you can make use of a line plot that you will see now. And you will see from the line plot, or you will see which students, or you will find that most of the students scored might be 60%. Of course, the number of this dot will show you that. Okay. The line plot can also show us the, if we had to have a look at this, this is a line plot. You have this line, and these are from the smallest to the biggest. This can be the marks of student. Okay. So to say that if you can look at this, you can represent the marks of student on the on the line plot, like maybe the least score, or the smallest, or the minimum score for the test, we can say maybe it was 17. and the highest score is, we can say it's 73. Okay, so this is now the range. All right, so you can easily identify that maybe one student scored only 17, only one student scored 17, so you put a star there or a dot there. If there are 2, you can continue up. If there are 10, you can put 10 crossing under that same number. Okay? So now the line plot can also indicate to you where most of the data are concentrated. Let's say we can be able to see most of our students scored around this range of 31 to 44, because we can see scattered a lot of stars are surrounding this area of 31 to what? To 44. So we can also make use of this, observations to indicate or to have an idea that most of our students scores between what? 31 and 44, because that's where most of our data appear, as it is shown here, if you can see. And this is a cluster, a concentration of data in this range. But for, again, using the same line plot, you can see that this one, hello, this is 51, 52. We can also make use of the line plot to identify the most frequent value in our data set. So to say that most of our students in numeracy test scored 52. And you can see the highest peak here tells you that.
This might minister.
Hello?
Damara.
Who is talking? Let me just mute this person who just came in now. All right, so you understand the line plot. What can it do and what information can you get out of this line plot? So from here, you can identify from the line plot. Of course, you have to arrange your data from the smallest to the biggest on the number line. You can be able to find the smallest and the biggest value. You can also be able to find the range. The range, we can say the range is the highest number minus the smallest number. So if you take 73, this one 73 minus 17, we can get the range. And we can also see that since these numbers, like this number 17 is far away from the rest of the numbers, we can call this number as an outlier. An outlier is a number which is isolated, that stand out from the other numbers, like in this case. So this 17 is an outlier because it's isolated. Also, this number 73 is also isolated from the rest of the data. So we can say 17 and 73, these numbers far away from the rest, we call them what? Outliers. Also, you can, the range, the bigger the range, you can also see that your data are spread out, or they are or we can say the range, your data's, or the wider the range, you can see that your data are more scattered in some cases. No? The smaller the range, you can see that your data are closely, they are too close to one another. Okay. So what you can see from your line plot, please summarize it here. You can be able to identify the outliers. You can see the mode, the most frequent value. You can also see where most of the data are concentrated. All right. And you can also do some kinds of observation where you can see gaps, where there are gaps existing, like between 17 and 28 here, you can see there's a wide gap. This gap tells you that this might be if in terms of if you want to address some of your issues. Like if you are teaching student, you realize that there's only one student who scored 17. So what can you do as a teacher? You have now to come and take this student and give some extra classes so that she can be close to where many of the other students are. Also, if you see that this student scored 78, you can also make use of that if you're a teacher. You can make use of this student to help others so that all these other students can score the same or they can score 73. Okay, it's a very easy way of representing your data. So what you need is to identify the range or the smallest number and the biggest number. And of course, when you do this plotting, the gaps or the intervals between the numbers would be the same. Okay. Another way of representing our data is we can make use of a stem and leaf plot. And in a stem and leaf plot, the data are organized from the smallest. It's almost similar to this one. Yeah? Again, here the data should be arranged from the smallest to the biggest value, from the least to the greatest value. The digits of the least place value from the least, and the next place value digit is from the just to make you understand what it means. If I'm to give you a number like this one, yes, because we are using that word stem and leaf, we are not talking about a stem for a tree or leaves for a tree, but what we are talking about a numbers. If we have a number like 22, let me say 25, we can now say the first number here is our stem. As a key, we can say 2 is our stem, and the next number should be the leaf, which means 5 should be our leaf. Okay. Now, if you have a list of datas, like maybe from, let me say from 25 to 95 of 50 observations, of course, you should be able to draw a stem and leaf. The characteristic of a stem and leaf is that is arranged from the smallest also to the biggest. So the data on the stem and leaf should be arranged in ascending order from the smallest to the biggest. So let's look at this example here. You see what I was talking about? This picture that you see here is what we call a stem and leaf. So maybe the question is, how did we come up with these types of plotting? How did we come up with this type of graph? So if you look at this, the first part, you always draw a line here where you have the other part, the base here is your stem and the other part is your leaf. So which means the number that you see here, the 10th digit of the data form the stems. And the other part will form the what? The leaves. Now, if this were the age of employee for one of the company, you can say these are the ages of NAST employees, of which some of the employees, the youngest employee in this at NAST is, we can say, is 26. And two of them, these two, the moment you see 6 like this one, it says 26, the first employee, and the other employee is also what? 26. The other employee is what? 29. Okay, so before you draw your stem and leaf, please make sure that you have to use some key, and the key will show you how the digits are related or how they were generated. Okay, so let me just write something here. If I'm to write this number, like the first number there is 26. The first employee is 26. The next employee is also 26. The other employee is what? 29. Then you come down here, you are done with the 20s, those employees that are in the age categories of 20s. Then we move to those ones that are in their 30s. So you can see there we have 30, we have 31, we have 33, and so on. And the oldest employee for this company, you can say what? Is 70. Is 70 years old. So that's the oldest employee. The question is, how many employees are in this company, if one might ask you? How do you get the total number of employees that are working for NAST? If you are given something like this, how do you get the total number of employees? Sister. Wilza, you don't need to get an exact number. Just tell me, how will you get the total number of employees? By looking at this.
Say you add.
You add?
Yes.
Are you adding or you are counting? It's just counting. No? You count
Just
these
count.
numbers, you count the leaf, the numbers on this side. 3 employees, 26, 26, 29. There are 3, isn't it? Then you
Yes.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this one we can say there are 15. I don't have that time of counting. So this number you see here represent the age of what? Of an employee. Okay, if you want to find how many are there, you can just count the numbers on the other side. You don't need to add them. Okay? Yes? Okay. Another usefulness of a statement leaf is that it's similar to the line plot. You should be able to find, because this is the smallest number. If you look at 26, this one, 26, this one, where's my pen? Where's my pen? Okay. I hope I got my pen. 26 is the smallest number, and 70 is the biggest number. So we can say that the range can be able to make use of the statement leaf to find out what? Our range. Another observation that we can make here is that our data are arranged from the smallest to the biggest. Because this is 26, next is 26, the third number is 29. Then we have 30, 31, 33. You can see the arrangement. Then you move to 40, 41, 41, 42, 45, 60, 69, and 70. So there is an arrangement that you can see here. A statement leaf is not just plotting number there, but there is some method or a way of putting this number that they should be arranged from the smallest to the biggest. If you put 29 here before 26, so that's not the right way of doing the statement leaf. Another usefulness or of a statement leaf is that we should be able to see the number that appears the most frequent value. We call it the mode. In this case, what is our model age? For most of the employee at NAST fall within which age category? By looking at these observations, how do you get the model value or the number that appears the most on this graph? How do you get the model age? or most of the employees falls within which age category? If you look at this number, this is 5 appears how many times? 1, 2, 3, 4. 4 times, ne? And this one also 4 times. This one 6 also appears how many what? 4 times. This one also appears how many? 5 here. Because these numbers are consecutive. 35, 35, 35. This one also appears 4 times. This also appears what? 4 times.
4 times.
Yeah, if there was in a case where you find that maybe this one appears like this 5 appears 6, you can say that the modern value or the number that appears the most is what? 35. You don't say 5. Remember, this is the other number. You say is what? 35.
5.
But if in a case where you find numbers appearing like 35 appearing 4 times, 45, 46, and 50 appearing 4 times, we can say that this is multimodal. It's most of the employees falls within multimodal, which means it's this many modal values. Okay? So you can also tell that most of the employee, by looking at this, the longest or the tallest, if you turn this one will become taller, né? Or the highest point here, tells you that most of the employee for these companies falls within the age category of what? Of 40. Because this is the highest point. And can you see that? Most of our
Yes.
this employee falls within this age category of what? Of 40. Because the highest point is at 49. If you count them, you can be able to find to get that. Okay, and you can also make use of, if you turn these things, or if you do some kinds of plotting. Sorry, let me clear my screen. If you do this, can you see what I'm doing?
Yes.
What can you see? You can see almost a triangle, something like this. Ne? Is it a triangle? If you turn it the other way around, it will look like a triangle. And this highest point, you say is this highest point indicates to you that most of the employees are in this age category. So the statement list can also be used to show the distributions pattern of our data. Are they normally distributed? Normally means are they equally distributed? In this case, if it's something like this, which means our data are normally distributed. But if you realize that you have the highest point here and this thing is pulling like this, it's pulling directions. It tells you that there are some few numbers on your right that are pulling your data from the highest point to the what from the from where they are concentrated to this biggest number, and we can say the data are positively skewed, or they are skewed to the what, to the right. This skewness later on when you do quantitative, you will come to realize what is the effect of this number when the data is pulling in this direction. What does it do to our data set? Okay, in some cases you will find some smallest number. Maybe you find those employee of which maybe that employee is just maybe 16. Né? It's mostly likely that NAST employed an employee who is 16 years of age. This number maybe is only one employee. This person is also isolated. Is pulling the age to, or most of is pulling our data set from where they are concentrated to that point. Ne? When we do some calculation, these points that are isolated, they tend to have an effect on our average, because an average takes into account all the numbers in the population. But these numbers that are isolated usually have an effect. In real analysis, in some cases, these numbers need to be removed, because it does, if you include it, it does not give really a true picture of these data representations. Ne? If you have an employee who is having 120, yes, if you take that, if you add all those numbers, it's most likely to pull the average age, which is in this case is going to be somewhere around 40, to that number. Maybe we are going to have an average to be what, 55, just because of this big number which contributed to the total. So that's the usefulness of a statement leaf. If I give you a list of numbers, you should be able to draw a statement leaf. Okay? So I give you a list of numbers like 70, and numbers will not be arranged. You'll be given numbers at random. Just numbers like that, might be 10 observations. And one person, and I will ask you to do a statement leaf plot. So which means what you have to do is to identify the smallest number. In this case, the smallest number is 15, and the biggest number is what? 89. So you have your stem starting from 1, then you have those other numbers that are not there. Just write them there. You just write 1, 2, 3, 4, 5, all the way up to what? Up to 8. Okay. And if the number is not represented and is in within the range, you put it there, but on the leaf you don't put anything because that number is not represented. No? Okay, so this is another way of presenting your data in a picture form. Okay, it gives you a picture already. You can come to the conclusion as quickly as possible. As long as you see this, if you know what is that, you should be able to make some interpretation just by looking at this diagram. Another way we have discussed about this in our previous lesson, the circle. The circle graph is the same as the pie chart. No? The circle graphs are used to show a relationship of parts. Because a circle, this part, these are portion of a whole. No? We have something like a student in Namibia, for example, and we can say 45% of the students in Namibia, they are in grade 1 up to 8. And 22% of the students, we can say they are in grade 9 and what? And 12. So a pie chart, I've shown you this one in our previous lesson. Please go back to our previous video and see how to do this plotting. It's very easy. Okay. Pie charts, it's just a way of presenting your information in a form of percentage. The other way of presenting our information is, again, we can make use of a box and whisker plot. And a box and whisker plot is a diagram that summarizes data by dividing it into 4 equal parts. Okay, into 4 equal parts. So what are these 4 equal parts? So if you have your a list of datas, remember always just to explain the points that you are seeing here. This point 1, 2, 3, 4, 5. There are 5 points. I will explain what each and every point represents. Though some of these things we did not do, when we do this calculation, at least you should know how to come up with a box and whisker plot, and you should know what it represents. Of course, the first thing is to find your range. If you have a list of data, this can be ages again of employees from 20 to 90. The smallest observation is 20. So you do your plot what? From your data set, you can be able to identify that 20 is the smallest and 90 is the what? The biggest. So you plot this one. Okay? Again, from the list of data, we know how to do the median. Okay, if we don't know, we'll do that one in our next lesson. So the median is the number which is the number in the middle of an arranged data set. So if you arrange your data from the smallest to the biggest, you should be able, the number in the middle of the data set, we can say you can plot it here. If you find it, arranging it you should always have a line plot like this. And the moment you find that point or that number, immediately you put your point there. The other two numbers that you see here, this one is the first quarter, quarter one, and this one is our third quarter. Okay, quarters. And for quarters, this is a way of saying if you have data that are arranged from the smallest to the biggest, if this is the first number, the moment you come to the second number here, you reached your what? Your third quarter, your first quarter. The first quarter represents 25% coverage on our data set. This is, let's say this is the first number, this is zero coverage in terms of percentage. If you are at 0 point, 10, 15, then the first quarter represents 25. If you are moving. And this one, this is 25, the percentile, and this one represents what? 50%. And coming here, this one represents what? It represents 75%. This one, a third quarter. So don't worry about this one. We'll know how to calculate, or we'll have another lesson to know how to calculate the quarters for ungrouped data. But just to understand what a box and whisker plot is, it's a summarization of four of the smallest number, the biggest number, the median, the first quarter, and the third quarter, just to know where to place them. This one is the smallest number, this is the first quarter, this is the median, and this is the third quarter. So we'll know how to calculate this one in our next lesson. Also in our next lesson, we'll be doing the calculations of the median, the mean, and the quarters. Okay. All right. Yes, now I would want us to look at frequency table. And the frequency table, this is just another way of summarizing your data that you have collected. Want to make a table of summarizations. Okay? And for the frequency, you should be able to have categories, and those categories you can divide them. And of course, making use of your tariffs and doing the relative frequencies. Hello. All right. So, yes, I would want us in our next class, guys, to look at these information. I'll send this same information to our WhatsApp group. Yeah? And I would want you guys to read and understand what is a frequency. We said, what is a frequency? It's a summarization of data, right? And I want you to form or to make the frequency distribution table. Then from your frequency distribution table, you should be able, again, to make or to come up with what we call the relative frequencies. and also to do the percentage relative frequencies. So the information is here. Please take this information and answer these two questions. This is a way of presenting or of having or summarizing data into various forms. It can be done in a table. A table like this is also a graph. Some information you don't need to do pie chart and whatever, but you can also present it in a form of a table. And this is what I want you to go and do. And once you have your frequency table, you can always come up, you can always do your pie chart, you can always do your line graph, and you can make use of your frequency distribution table to present this information in other forms of appropriate graphs. All right, in this, to end our lessons, we have learned how to present our data using various graphs. And of course, now you should be able to answer this question and also to answer this last question here. Again, this one should be, you should do this one, you should calculate the relative and cumulative frequency for this data. In our next lesson, we will look at that. Unless we have some questions, because we only have 3 minutes remaining. Unless if there are some questions, you can ask me questions if there's something that you don't understand. Will you be able to, yes, will you be able to answer these questions? Lisa? Oh, you can. Yes, you can. Yeah. So if no response means that you can. All right, guys, if you don't have any questions or concerns,
yes, we don't understand about to stem and leaf there.
You don't understand the stem and leaf.
How to find it?
How to
now,
get
say we
Yes.
mean how to find the mode,
no.
mean, and median.
Don't worry about those things. We'll come and do it in our next lesson. Yeah?
Oh,
Yeah, this
Okay, sir.
for those calculations. But this is just graphs. Because a step
okay.
plot is a graph. A dot plot and whisker. These are all kinds of plots. Some of the graphs, like the box and whisker, require us to calculate the median and also the quartiles.
Okay, sir.
Stem and leaf is very easy. Remember,
next lesson is when?
when are we having our next lesson? On Monday?
On Monday.
Or is it tomorrow? Check your time.
Tomorrow is fine.
You want us to have it tomorrow?
Tomorrow, yes.
Okay. I'll do that so that we can. I'll just remind me, ne?
And tomorrow, what time, say?
Hmm?
What time?
Just remind me.
Okay.
So that we can come and look at some examples.
Okay, sir.
All right. Enjoy your day.
Have a nice day.
All right.